Hello and welcome to the second part of 5.9. To get started, I'd like you to find the slope and the y-intercept of each line. So pause the video and just take a moment to do that for each of these two equations. And taking you through quickly, we're going to add 3x to both sides. Y equals 3x minus 2. So my slope is going to be 3, and my y-intercept is going to be negative 2. And on the other equation, I just have to move the coefficient of the y term. Divide by 3, these cancel. Y equals negative 1/3 x minus 11 over 3. Remembering that there's a 1 that's right in front of that x coefficient, excuse me, so that's why our slope's going to be 1/3. So m is going to be, negative 1/3, and our y-intercept is going to be negative 11/3. So we're going to be exploring these types of slopes. So just starting to think about the relationships between the two of them. So now what we're going to do is we're going to graph each line. The first line we're going to do is right here. We're going to start at positive 2. And we're going to rise up 1, run 2, rise up 1, run 2. So here's this line right here. And what I want to really focus in on is the slope. The slope is 1/2. We have a positive line. So for the second line, we're starting at negative 3. And our slope is negative 2, negative 2. So we have our 2 points, and I can go ahead and connect them. Now look at the relationship between these lines. I have a positive line, and then I have my negative line, and the point at which they intersect creates a 90-degree angle. What we call these lines are perpendicular lines. So when two lines intersect and form a 90-degree angle, those lines are perpendicular. And the key to identifying which lines are perpendicular is right here in the slope. One of my slope is positive 1/2. The other slope is negative 2. And if I actually took those slopes and multiplied them together, I would get negative 1 over 1 as my slope. This is identifying the fact that they're perpendicular, because when I multiply the slopes together and get negative 1, then the lines are perpendicular. And we'll explore this in a little bit. Another situation in which you can get perpendicular lines is when you have horizontal and vertical lines. Remembering when we graph these, if y equals 3, I can go to the point where y is 3, and I know all the points to the right are going to be 3 as well for y, and all the points to the left will be 3 as well. Graphing x equals negative 2, I'll go to the point where x equals negative 2. I know all the points above are going to be negative 2 for x, and all the points below will be negative 2. So when I have both a horizontal and a vertical, these lines are perpendicular, and they will form a 90-degree angle, so these will be perpendicular. Okay, so this is the second way in which we can have perpendicular lines. So perpendicular lines intersect to form right angles. And two non-vertical lines are perpendicular if their slopes have a product of negative 1. Ooh, my mind is not writing well with or working well with my hand. Their slopes have a product of negative 1. So product means multiplication, and negative 1 is negative 1. So if I were to have a slope of 3 for one of my lines, so if m equals 3 for one line, the line perpendicular to that would be able to be multiplied to this 3 and create a negative 1. So 3 times what number equals negative 1? Well, it's going to be a fraction. It's always going to be the reciprocal. So if I flip 3 into its reciprocal, it becomes 1/3. And in order to have a negative product, I need a negative sign. So therefore, negative 1/3 would be the slope I would use to have a perpendicular line. Which lines are perpendicular? I'm going to look at A and pick up the slope. Because it's already in slope-intercept form, it's easy to identify. So M equals -3. We know in order to be a perpendicular line, we need to have the opposite sign and the reciprocal of the slope. So the way I look at it is, if this is -3, I need my perpendicular slope to be positive, and if this is a 3, it would be the reciprocal, which would be 1/3. So the slope of the perpendicular line would be positive 1/3. Here my slope is 2, so it's not that one. For C, my slope is 1/3, therefore 1/3 and -3, these two lines would be perpendicular. So A and C. So let's go back to B. The slope here is 2. And I'm going to approach this a little bit differently. So if the slope is 2, if M equals 2, 2 times what number equals -1? Well, since 2 is positive, the number would have to be negative, and I know it'll be the reciprocal, so it would have to be -1/2. Just to prove it out, these would cross cancel, and that would give me 1. 1 times -1 is -1, so it would work. So I would need to have a slope of -1/2 to be perpendicular to line B. When I look at D, oh, I have a slope of -2, so that's not going to work. So the only answer to this question is A and C are perpendicular lines. Which lines are perpendicular? In order to know which lines are perpendicular, we have to have them in slope-intercept form, y equals mx plus b. So I'm going to start working on this equation here. I'm going to subtract 2x, subtract 2x. The reason why we need it in y equals mx plus b is so that I can easily identify what my slope is. So here my slope is -2. So a line that would be perpendicular to this would be the opposite sign, so it'll be positive, and then reciprocal. So 1/2 is the slope it would have to be. When I look over here, I see the slope is -1/2, so these two couldn't possibly be perpendicular. So here I already have my slope as -1/2. Let's go down to the bottom right. I'm going to divide everything by 2, divide everything by 2. Y equals 1/2 x minus 6. Remember, there's a coefficient of 1 here, so we have the 1/2 as our slope. My slope is 1/2. Oh, and that's what I identified as needing to have over here for these lines being perpendicular. So the answer to this question would be that 2x plus y equals 8 and 2y equals x minus 2 are perpendicular. I usually just abbreviate and put perp. Okay, so let's move on. Writing equation of lines involving perpendicular slopes is very similar to parallel. The only difference is that we know if the lines are perpendicular, the slopes are going to be the opposite sign reciprocal. So typically they'll give you 1 point on the line and another line that it's perpendicular to so that we can get that slope. And then we just have to find the y-intercept algebraically. So lines are perpendicular if they have the opposite slope. So A is positive and B is negative. Notice that they have different y-intercepts. So that's why we have to find for the y-intercept algebraically. Note, the only thing you can take from the perpendicular line is the slope. The rest of the information we do not use. So we just want that slope so we can figure out how to write the line of the equation. The equation of the line. In this example, we're going to write an equation of a line with a y-intercept of 3, so that's key information, that is perpendicular to a line represented by this equation here. Okay, so I always set it up, y, x, y, mb. What do I know? Okay, I know that my y-intercept is 3. The y-intercept is the b value, so I have my 3 here. I know it's perpendicular to this line here. So let's figure out our slope. If it's perpendicular to a line with a slope of 3, I know it's going to have to be the opposite sign reciprocal. So if we test that out, multiply it together, these cross cancel, it becomes 1. It ends up being -1, and that is our correct slope. So our slope for a perpendicular line would be -1/3. writing the equation of the line, y equals negative 1/3 x plus 3. So even though I lay it all out, the m and b are the only values I need. And I always identify by writing x, y, and b what I have so that I can work toward my equation. So we're going to try one more, which you'll finish up on your own. Write an equation of a line which passes through point 2, negative 1, and is perpendicular to the line represented by the equation y equals 2x minus 5. So x, y, m, and b. All right, so in this situation, I have an x, which is 2. I have a y, which is negative 1. I know it's perpendicular to the line with that slope, so now you need to figure out what your slope will be. So I'm going to pause here, I'm going to end the video here, and I would like to see your equation written out for me. So you're solving for your m and your b in this situation for a perpendicular line. Thank you.